Okay, so this is logarithmic differentiation. To start off, it's y equals 1 over x to the 8x. To get rid of the fraction, I move negative 8x up, and then I ln both sides. Then I rewrote it using the property of logs, which the exponent then goes in front of the ln on the right side. So I took the negative 8x and put it in front of the ln right there. And then the x is just on the other side. Now I differentiated both sides, so the left side will always be 1y dy dx, and the right side was a product rule, so I did the product rule for that side. Then I have to solve for dy dx, so I multiplied it by itself to get dy dx alone on the left side, and then that's my answer on the right side. Okay, so then the next problem, I have my original equation. The domain is all real numbers, and then I am looking for the derivative of the first equation. So for that, I get 6x squared plus 6x minus 12. I take out the 6 to solve for points, and I get x plus 2x minus 1, which equals x equals negative 2 and 1. You put it on a number line, and then you test for, I usually always start to test with 0, so I tested for 0. I get a negative, and more often than not, it's alternating, and in this case, it is a different case, so it's alternating. So I got plus minus plus. The increasing is where it's a plus, so it's negative infinity to negative 2 and 1 to infinity. The decreasing is where it's minus, so it's negative 2 to 1. And the maximum is negative 2 to 24. And you plug in negative 2 to the original equation to get that. And then the minimum is 1 to negative 3, which you also just plug 1 in to the original to get the negative 3. And you find those when the signs are switching. The next problem I have here is a sketch graph. You're looking at the graph and you're looking for concave up, concave down, increasing and decreasing. There's also vertical asymptotes where it doesn't equal anything. That's the dotted lines. Concave up is where the graph is making that U shape, and it's from 1 to negative 1. And concave down are the downward U shapes, which are from 3 to 4 and negative 3 to negative 5. It's increasing from 5 to infinity and decreasing from 8 to negative infinity. The next problem is optimization. A commodity has a demand price function modeled by P equals 100 minus 0.5x, and a total cost function modeled by C equals 40x plus 37.5. What price per unit yield a maximum profit? P. Well, profit equals revenue minus cost. So to start, I'm finding the revenue, which is P times X. So I take the P function, which is 100 minus 0.5x times X, which will get you 100x minus 0.5x squared. Well, you already have the profit function, so 100x minus 0.5x squared, which is the revenue function we just found, minus the equation they gave us for profit, which is 40x plus 37.5, would equal negative 0.5x squared plus 60x minus 37.5. Well, you find the derivative of that, which equals negative x plus 60. So you solve for x, which is 60 units. Then you go back to the P function and you plug in 60 to get the maximum profit is $70. Okay, here you're finding the indefinite integral. So it gives you this equation and you're using U sub. So U sub is where you take out an equation to solve the problem. So you take out 4x squared minus 12x for this one. And then you find the derivative of it, which is 8x minus 12 dx. And then you sub in u, you just use the u, and since 8x minus 12 cancels out, it'll just be u to the 4th du. So then you integrate that, which would be u to the 5 over 5 plus c. So then you plug u back in to get 4x squared minus 12x over 5 plus c. Okay, the last problem I'll be explaining today will be indefinite integral, which you start with 4x dx with the bounds 0 to 4. So first you're going to integrate that 4x squared over 2 with the bounds of 4. So you always plug in the numbers and subtract them from each other. So you plug in 4 to the integrated, and then you plug in 0 to the integrated, and you subtract. So it's 4 times 4 squared over 2 minus 4 times 0 squared over 2, which will equal 64 over 2 minus 0, which will equal 32. So your answer for this is 32. Well, when you're finding it using geometry, you graph it, which is 4x, so it's up 4 over 1. So I covered it up on accident with my line, but I graphed the line up 4 over 1 to where I got to 16, and which is the height, and 4, which is the base. So it graphed a triangle, and the area of a triangle is 1/2 base times height. So I plugged in 1/2 16, which is the height, 4 is the base, to get 32.